soon as you saw that it was doing character set conversion, it becomes obvious that it's something to do with locales. And so changing your locale solved the problem. The real thing, though, what should be done is fix the character set handling routines in the C library. Again, it's Ulrich's fault. We're really bashing up Ulrich tonight, aren't we? I'm going to get in trouble. So the icon library does have some performance problems in glibc. On most systems, in fact, it's pretty slow. So it's partly why I wrote my own icon library in Samba, because it's much faster. And we do a lot of string conversions in Samba all the time, because we have to juggle 4 different character sets simultaneously. There's two different character sets we get from Windows on the wire. Then there's the character set of the Unix file system, and there's the display character set that's being shown to users. And so these 4 character sets, we are constantly juggling and converting strings between them. And so we need a very fast character set conversion library. And the standard system libraries are just too slow. So we ended up doing our own. Anyway, so so I've shown you now strace to show system calls, and I've shown you ltrace to see library calls. The next tool, GDB, the GNU debugger. How many of you have used GDB? A few more? Good, okay. GDB is really worth learning. Usually just start on your own simple programs and then use those simple programs and debug them with GDB, put a bug in and catch the segmentation fault to do a backtrace. Another opportunity here, I can tell you about a bit more of junk code. I've got another tool in my junk code directory, which is really handy. I'm sure somebody here will find it useful.
Andrew, are you selling this off on a CD or something?
What?
Are you selling junk code off a CD or something?
It's free.
You should.
It's free. Okay. So this is something quite useful, and what I'll do is I'll show you. I'm running a whole lot of processes here. Right? Now say you wanted a backtrace of one of these processes. Usually you'd have to attach the debugger, that sort of thing. But let's have a look at this process 748. Okay? We can just go backtrace 748 and it gives us an immediate backtrace. Error in source command no stack. And so it doesn't work. So, but I'll show you the idea of this segv handler. The idea is this is a hack. Okay, this is, you know the term hack, it's used a lot in the open source world. It has many meanings. It can mean this is a good piece of code. It can mean this is a terrible piece of code. It usually at least means it's an interesting piece of code. Yeah, at least interesting. You say, oh, that's a real hack. You know, that's a bad piece of code. They say that, oh, that's a beautiful hack. That's a good piece of code. It's very strange that way. Anyway, so this is a hack. Said with an even tone, and this is a very short hack. So this is the whole program. That's the whole program. What it does is because the lighting isn't so good, what I'll do is I'll put it up the top of the screen. Is that a bit clearer? Yeah. Is it possible to turn off the board lights? I'll probably end up turning off all the lights. Can I turn off just the board lights? Row 1 front. Hey, great, much better. Okay, so this is an LD preload hack. Any of you know what LD preload is? Oh, LD preload can be wonderful for little hacks like this. LD preload is a way, you have a C library on most modern Unixes, and sometimes you want 1 or 2 functions in that C library to be different. You want a little change in the C library. LD preload is an environment variable that says, when I start any program, insert this bit of code. Squeeze it in there as it's starting the program. All right? So this is an LD preload hack. What it does is, when the program, any program with this environment variable set starts, it will run this init, and it will set a segmentation fault handler, so an error handler. So if any segmentation fault happens in this program, then it will generate an instant backtrace. It will launch GDB on itself, very introspective. So it launches GDB on itself, produces a backtrace, and logs it to a file. Yeah? So the reason I wrote this is I was working for a company that I won't mention the name of, and not my current company. And they had some programmers there, if you can call them that. And these programmers wrote the GUI system for this, this NAS box, Network Attached Storage Box. And they had lots of bugs, lots and lots of bugs. And so if any of you done CGI programming, it's very hard to debug CGI programs because it's hard to attach with the debugger. So their programs crashed all the time, and they couldn't work out how to debug them. They were doing their GUI CGI programming in C. And I know the first letter of CGI is C. That doesn't mean you should write it in C. There are other languages more suited. Anyway, so it was all in C, and lots of bugs. So I wrote this because this allowed us to install a global segmentation fault handler across the whole system, the whole NAS box. So you put it in etc ld.so.preload, which is a file that the loader reads for every program across the whole operating system. And if any program dies with a segmentation fault, then it will produce a backtrace and show you what went wrong. And you can then gather those backtraces up. So very useful. So I'll demonstrate it to you. So let's see, there's the .so file. So ld preload equals home tridge junk code segv handler.so. Right? I'm doing it as an environment variable. You normally do it in an etc file, so it covers all programs. Yep?
Really quick question. In your junk file, junk code, do you have a little readme what the different functions do?
Yes.
Okay, cool.
There's a website, junkcode.samba.org. and that website is powered by junk code. I've written my own server-side scripting language because one has to. It uses embedded Bourne shell, so you can write, instead of PHP or Perl, you can do embedded Bourne shell scripting, including recursive evaluation. But it's very, very small. It was done for an embedded box where we had very little RAM, and very little memory and ROM, and we needed to fit the whole of this server-side scripting system. Anyway, so the junk code of Samba.org is powered using that. Well, see, the managers had already decided to put bash in because they needed bash for init, right? And so we already had paid the price for bash. And when you've paid the ½ megabyte for bash, you really don't feel like also paying more for Apache and things. So this system is actually a web server as well. Anyway, you can read about it. It's called T-server, trivial server. It's quite useful. Okay, so LD preload, and if we now run it, we can run programs and they'll work. Now, if we strace ls now, then it will be a little bit different. Because when we strace ls, you'll notice that it's opening my segv handler as part of ls. So it's injecting this extra little bit of code at the start of ls. Yes, injecting the extra error handling code at the start. Now we need, of course, to run a program that has a bug. Yes? Now, I don't have any, so I had to create one, of course. So I've got this little testprog.c. This is a little program that has a bug, and it dereferences 3. Okay? It's a bug. That's bad C code. So if I run this, then if we look in /temp, what we see is this output. Right? That gave the full backtrace, and there's the values of the variables that were set at the time of the error, and it explains, it gives the line of code that it gave the error, a full backtrace. So whenever any program on your system dies, you get a log in /temp, the name of the program and the process ID. Very useful for developers that have lots of bugs. So there you go, maybe there's, not that I ever use it, of course. Right. So you need to learn your tools. GDB, so this is a way of using GDB in an unusual fashion, and you can have a look at that script as to how it works. Valgrind is another tool that's fantastic, really, really fantastic. How many of you have used Valgrind? Oh, isn't that tough to use? Yeah, let's use it.